Hello dear friends and welcome to the GEOCOAST. Today we're with Jimmy Murphy in the Murray Centre in Cork Harbour. Hello Jimmy.
Hello Max, pleased to meet you.
Jimmy, can you please tell us a few words about the work that you do here?
Okay, so I just described myself first. My name is Jimmy Murphy. I'm a senior lecturer in the School of Engineering in UCC, and so for the last 25 years I've been working on research in UCC related to coastal engineering and offshore renewable energy.
What would be the main focus of your research at the moment?
Okay, I suppose all through my career I've been working on coastal engineering, and I continue to work on coastal engineering. So that work involves a number of different aspects. It involves physical model testing of coastal structures. It involves going out on site and measuring beach processes and beach behaviour. And also it involves numerical modelling, so whenever you want to change the marine environment, what we do is that we create a numerical model of it, and we examine the impact of developments on that marine environment. So we do a lot of studies looking at piers, harbours, coastal protection works, discharges such as sewage treatment plants into water bodies and their impact on the environment. So that's one whole aspect of what I do. A second part of what I do relates to offshore renewable energy, and offshore renewable energy refers to wind energy, wave energy and tidal energy. So there's an incredible resource available in Ireland, particularly for wind and wave, that is not exploited at the moment, and our job here in the Murray Centre is to try and develop technologies that are capable of operating and surviving in that marine environment. So again, we use techniques such as physical testing, which you will see later in the video, and numerical modelling as well, to understand how these structures will behave, how much power they'll produce, and whether they can survive wave conditions which can be as high as 30 metres.
And talking about coastal engineering, from my own personal experience, I know it's quite important in the context of coastal zone management, and especially in the context of potential climate change and sea level rise in the future. So you've been doing this, as you said, from mid-90s,
Yeah.
And from your point of view, has there been any technological advance in the technologies used for coastal protection over the last 25 years? Or are we still using the same techniques?
What I would say is that the methods and techniques that we employ are the same as that were used in the mid-1990s and even before that. But what I would think is that our understanding of their impacts on the coastal systems are better now than they were then. So back in the 90s and 80s, you deployed revetments and detached breakwaters and groins and all that, but it wasn't fully understood what impact they would have, and even still at the moment we don't fully understand the impact of structures on a marine environment, but we are improving all the time through techniques, better modelling techniques, better monitoring of their behaviour. So I think while methodologies and techniques for protecting our coastline are largely the same, we can pick our technique better now.
So mix and match them in a better way.
That's right, yeah. Because in the past you could put a groin where a detached breakwater would be better. So we can better fit a solution to an environment now than what could be done previously.
And correct me if I'm wrong, groins are kind of parallel fences.
That's right, yeah.
Which so perpendicular to the beach to stop longshore drift.
That's right, yeah. And I think in the past, what I've seen in a lot of locations is that groins were put in places where there'd be no longshore drifts, and if you have no longshore drift, there's no point in having a groin. So they're pointless in that situation, and there's a lot of examples in Ireland where that has been done.
So, for example, in Youghal, I think they're kind of semi-destroyed, and they've probably been put in
right,
way before 90s.
That's right, yeah, and there's examples in Bantry and Waterville as well. So for groins, you need a movement of sediment along the coast. So you need sediment, and it has to be moving in a certain direction. And if you don't have those two things, there's no point in groins.
I think, if I remember correctly, I've seen groins on one of the paintings from 1800, from the 19th century, somewhere in France. So it must be an old technique which people
It
use
is,
like for a long time, like over 100 years.
It is an old technique, and it's a technique that has been successful in many locations and unsuccessful in many locations as well, because sort of the attitude was that if it works in this location, it can work in another location as well, and it will just fit it on locations where it wasn't suitable. But now we know through modelling and monitoring the best locations to put groins and what their impact will be on an environment.
So, but does it mean that even in 19th century people were already concerned with longshore sediment drifts?
They were concerned with erosion, in terms of protecting infrastructure along the coastline. I suppose that was a concern back then as well. I suppose historically, sort of people like living close to the sea, and my view is people live too close to the sea. So to be a lot better if we didn't have to put structures in on the coastline.
And from your knowledge, like you've been designing and kind of advising the government on what type of coastal infrastructure to put in place, except groins, what other coastal protection techniques go back in centuries, in other words, like what could be related to technological heritage, if you like?
I suppose, sort of revetments and walls are the most common methods used. The easiest way to solve the problem is to put a physical barrier in the way of the water, so that has been in the way of walls historically. So sea walls in the 19th century were very common, but what happened then is that they had a very negative impact on beaches, in that all the sediment was pulled out in front of the wall, and a lot of these walls collapsed.
Because of the backwash.
That's right, of reflection and scouring at the base of the wall. So obviously vertical structures aren't a good idea on a soft coastline, so that's a lesson that has been learned a long ago, but revetments are a good solution in a lot of locations,
It scatters the energy of the wave.
It's scattered, you break the energy over the structure, so in the past, and you see examples around Ireland of revetments, and they're sort of vertical, the rock is stacked.
Yes.
And that's a bad idea, sort of in terms of the impact on the beach, but sort of new revetments sort of have a much flatter slope, and when you have a flatter slope, the wave breaks over a longer area. Like I remember back in, I think it was the late 1990s, early 2000s, I was involved in a scheme down in Waterville, it's called the Inny Beach, for the golf course there, and I was pushing for a very flat slope revetment, it's sort of a slope, it's called 1 and 2.5, so every one vertical you go across 2.5, so it's a flat slope. And the problem with a flat slope is that it requires a lot more rock, and
it's more expensive
to build. But the golf course went with it, and prior to the revetment being built, the people couldn't walk along the beach at high tide because there wasn't enough sand. The water level would come right in to the dune face.
So it has changed.
So when the revetment was built, what happened is that the waves came in and they washed into the revetment, and the sand was deposited, and the beach levels rose, and it improved the beach.
Okay.
So you can get a positive impact in certain locations from a revetment if you build it right. But at the same time, you don't want revetment everywhere. We don't want our whole coast covered in rock.
And can you give us some more examples? What other work have you done around Ireland in terms of about coastal protection?
Well, I've done a lot of studies just looking at the coastal environment. So, for instance, sort of you're trying to understand how the coastline behaves, and every section of coastline, behaves in a different manner. Say, for instance, sort of back in 2008 down in Ross Bay in County Kerry, there's a beach system there, and the dune system was breached by a large storm. So we've been looking at the behaviour of that system since, in terms of its recovery and where the sand has been going. So when the dune system breached, the solution that was being proposed at the time was that we should try and repair it and fix it. And I think what our study has...
Beach replenishment.
Beach replenishment, or building a structure there, sort of, because the water was coming in into the area behind the dune system. But our study has shown that, that such events could have happened previously in Ross Bay, that it's a long-term morphological behaviour of the local system where you can get redistribution of the sediment, you see. So what we've been studying is that the sediment it's being eroded from the beach and it's being carried offshore into bars. So there's huge offshore bars in Dingle Bay now off Ross Bay Beach, which are being slowly migrating back towards the shoreline. So our sort of 20-30 year prediction of Ross Bay is that you could get replenishment of the dunes naturally and build up of the beach again.
And you achieved it through numerical modelling, isn't it?
Through numerical modelling, yeah. And like beach monitoring, so we're monitoring where the sand is going and then we're trying to match that with the numerical models.
Have you actually used the data collected during monitoring for your model?
Yes.
Yeah?
Yes, so we're trying to validate the model using the data we measure. So we take surveys down there every year, so we see where the sand is moving.
And what methods do you employ for your coastal monitoring in Ross Bay?
We started off with sort of just a GPS and walk it. Now we're using drones, you know, so we have a drone that flies the beach system and we can pick up the levels, and as well as that we have
With the drone, do you actually see the elevation of sand, or do you only look at the position of the coastline?
No, we get the elevation of the sand, so
So you're not using a normal camera?
No, well, we are using normal camera, but we're using photogrammetric techniques to get the levels, you know. So what we're doing is that we at various points along the beach, we put down markers of known levels, and then we relate the levels of the beach to those markers then, you know. So we do level surveys of the beach to determine, you know, what changes have occurred. And as well as that, you know, sort of drone surveys can only do the visible beach. You know, it's what's offshore is important as well. So
in the intertidal area.
That's right, and even beyond that, you know, so where the sand is going, you know, so the sand is somewhere offshore. So where is it offshore is the question. So we have a jet ski where we've fitted an echo sounder to.
Multi-beam, is it?
No, it's just a single beam, you know, so we can go out and we can survey the near shore area and determine, you know, sort of where the sand is, where the sandbars are, how much they've moved since the previous survey. You know, so all of that is helping us understand the system over time and how it's evolving.
And I remember back in 2012, I had a research student working in the same area, doing also a short coastal monitoring project over 1 year, and just using a DGPS. And I think the findings of the project was that the beach levels, the vertical beach level, changed by 4 meters between seasons, winter and summer. Did you get similar results? Or?
Well, what we're finding is that, you know, sort of, I don't know what section of the beach you were looking at, but, you know, sort of it was the furthest north section of the beach that was eroding, and, you know, there was a breach that started off maybe 100 meters, and it's widening and widening, and there's been, you know, since we've been looking at it, which is over 10 years now, there's been incredible change. You know, you go there season on season, and, you know, sort of it's.
But I mean, like the vertical sediment levels, have you measured those?
We have, yeah, we've measured profiles across the beach.
And what would be the difference between summer and winter? How much sediment is lost during winter storms and then replenished back?
Well, I suppose it depends on what parts of the beach, you know, sort of that you're looking at.
What's the most extreme?
Yeah, you were looking at a few meters difference, you know, in certain cases, you know, sort of. So it depends, you know, sort of sometimes you're looking at the dune. There was a dune there the last time we monitored, and that's gone now. Okay. So like the profile has changed completely in that period. And we tried tracking the sand using coloured particles, you know. So
did it work?
No, it disappeared. You know, so it's a very mobile, dynamic system. You know, sort of that's hard to monitor. You know, sort of and.
And do you still continue doing?
We do, yeah.
So you've been at it for like 10 years now.
10 years now, yeah. Like, and what we're hoping to show is to validate the predictions that we made 5 or 6 years ago and justify.
At the time you already run the model.
We run the model, yeah.
So do you see any matches?
We do, yeah. We in terms of where the sand is moving at the moment, and I suppose that decision we were advising Kerry County Council and the OPW at the time that, you know, if you shouldn't interfere with this system, you know, in terms of physical works. You know, sort of what we were sort of saying is that a more managed retreat sort of approach should be adopted because, you know, sort of, you know, the Ross Bay Beach was a barrier beach that protected areas behind it, and those areas were being affected now because the water was coming through the breach. So if you're doing any protection, you protect those properties rather than doing anything directly on the beach.
I remember actually back in 2000, maybe 14, I got contacted by Irish Times and they asked my opinion about the same thing, I think after the winter storms. And at the time, just from the top of my head, I said, I understand it's very expensive and it's not going to be done, but in my view, it's a good idea to put offshore wave breakers to actually slow down the erosion and change it more towards the positional environment. If money wasn't the issue, would you agree with this, or do you prefer to do nothing?
I prefer to do nothing because at the moment you have so much sand offshore. They act as breakwaters, you know. So a lot of the energy now is being broken further
by
from
the sandbar.
By the sandbar. The sandbar swings right down around in front of the beach now, you know. So it's protecting a lot of the beach. What is happening is that there's a longshore current running along the end of the beach, and then any sediment is being pushed along that and out of the system, out into the bay, and we think it'll eventually find its way back into the beach again. So I suppose I wasn't in favour of doing any works on that system because it was a completely natural system that was evolving and behaving itself like it always has, and we thought in the past it could have breached as well and repaired itself. So why not let nature do the work rather than
the natural balance?
That's right. Yeah.
And can you give me more examples of the actual coastal protection, engineering coastal protection work that you've done around the coast? Advice to like suggest the particular design of like seawalls, reverberants?
Okay, yeah. I suppose a lot of our work really, you know, sort of looks at determining the wave climate, and then we give the information to engineers, and then they sort of they develop the solution. So a lot of the information we've done or the modelling we've done, there's a solution such as revetments already proposed, and we look at the impact these revetments would have. But in a recent study along the east coast, we were looking at different options, you know, so we were looking at detached breakwaters, you know, because, you know, so there's a lot of vulnerable coastline along the east coast of Ireland, and, you know, which in the future would need to be protected. So what we did is we did a study where we ran modelling to determine what would the position of the coastline be in 2050 and 2100, and then determine what sort of solutions would be appropriate to reduce that level of erosion depending on what assets were at risk.
And you know, like from the old Ordnance Survey of Ireland mapping, you can see how the coastline changed over the last like 150 years.
That's right, yeah,
so there's old maps from 1800, and if you compare what we know by fact, by how much the coastline was eroded over the last, let's say, 100 years, and what your numerical models show for the future, for the next 100 years, how does this compare, the past 100 years to the future 100 years?
Well, I think a thing about numerical models is that you can set them up to give nearly any answer you want, you know, so if you let them run without any link to reality.
But I guess you input some of the results of coastal monitoring that you do now.
Well, I suppose the model study we did was for the whole East Coast, so we didn't monitor the whole of that. So what we did is we took the Coastal Protection Strategy study, and what they had done is that they had looked at erosion along the coastline from all old Ordnance Survey maps, aerial photographs of all that, and they said this section of coastline is eroding at a rate of 0.5 metres per year, for instance, and then they predicted 2030 that it would continue at that rate, you know. So we use sort of baseline figures like that to tweak the model.
You actually use the historical data to predict
the future. That's right, yeah.
So what is the point of doing the model?
Because what we did is we did that up until 2030, you know, because there was predictions given until 2030, and then we just let the model run free from 2030 to 2100, you know, in terms of once we set that the model was generally behaving itself properly, you know, sort of we set a increase in storminess and sea level rise and all of that, so that's what the...
When you say sea level rise at the rate of like 3 millimeters per year?
3 millimeters per year over the next, you know, 70 years or what, 80 years, you know, so we set that and then determined what the model would give us then from 2030 to 2100. You know, so I suppose the problem was that we needed to tie the model in to some known information, and that was the best we could do for those particular locations.
So you're saying that model is still running?
No, the model is done now, and what we came up with is as coastline position at different locations along the east coast for different time periods, and then based on that we decided on solutions that would be appropriate. So some cases it would be groins, other cases would be detached breakwaters, and other cases would be nourishment. You know. So to me, nourishment is a good solution. Sort of especially on soft coastlines, but it's not used in Ireland that frequently because
of the cost.
Well, it's the recurring cost rather than the cost. You have to do it again and again and again. Sort of every 5 to 10 years. And when you're funding a project, you like to fund it and it's done, and you don't have to revisit it. So I think in Ireland we need to sort of adjust our attitude towards nourishment. It's the most common technique used worldwide, but in Ireland we don't use it, because of this recurring cost sort of problem.
Like in the past, I was trying to kind of suggest, even like to people in the government, that we should set up a national coastal monitoring program. Probably you've been thinking along the same lines.
I have, yeah. I've been talking to the OPW for a long time in terms of deciding where are critical locations in terms of coastal erosion and locations where we would eventually have to do some extensive protection work.
So we're talking about depositional coast or coast formed with glacial till?
We're talking about soft coastlines,
yes, yeah.
And we're talking about coastlines as well, not just say where there may be sort of relatively, I wouldn't say unimportant, say if you say farmland or sort of land, not
with commercial value.
Low commercial value. You wouldn't monitor those locations. For instance, you'd monitor say like towns. Say if you take like towns that are very close to the coastline, like Lahinch and Kilkee and Waterville. There's a lot of towns like that. They eventually will have to alter what they do in terms of coastal protection. So I was saying that the government OPW should pick locations that are strategically important and will at some point in the future require coastal protection, and start monitoring those on an ongoing basis. And from what I understand is that the OPW plan to do that. They plan to pick 5 or 6 locations, instigate a monitoring program, because say.
But again, would it be like a 5-year program or 20-year
or
50-year program?
To me, what I understand, it's a continuous program that they will continuously monitor.
Because I think it would be clever to fund a program similarly to INFOMAR, which is going to run for many years.
It would be all right, yeah. Because sort of a lot of times when a consulting engineer has to design a coastal protection scheme for a location, there's no information on how variable the beach is and what are the main processes that are occurring there. When you look at a beach at any instance in time, it's like a snapshot. You don't have the full picture, so monitoring would give you that.
And also you said, Jimmy, that you worked a lot on the renewable energy.
That's right, yeah.
So are you actually designing the devices, or are you thinking how best to install them, or what is your work about?
Sometimes we design devices, sort of part of research projects here, but primarily we test technologies that have been developed by external people, sort of developers or SMEs and things like that. So they come to us with their technology, and we do numerical modelling and physical modelling of that, sort of in order to show whether the technology works, how much energy it produces, and whether it can survive the loadings and wave conditions.
And how long have you been doing this type of work?
Well, the centre has been doing it for 30 years. I've been doing it myself for about 10 or 15 years now. So I've
the centre in HMRC.
It started off the HMRC, then it became MARA.
Yes. And from your point of view, currently, what are the best kind of renewable energy devices which are practical?
Okay.
Is it only wind turbines, or because I know tidal wave?
Yes, tidal and wave. Yeah. So I suppose
not commercially viable yet, is it?
No, they're not. So offshore wind is obviously a viable commercial industry, but it's mainly fixed wind. So wind turbines that are directly fixed to the seafloor through monopiles or jacket structures, so they're commercial. But the next stage is floating wind, and we're doing a lot of work on floating platforms.
Has anybody done it yet?
It has been done, yeah. So it's at the pre-commercial stage now, floating wind. Sort of there's a huge resource for floating wind, but the technologies are there, and there's a lot of companies now developing floating platforms, to try and get to become a market leader in the
industry. Are you designing your own floating platform, or are you using the ones which
we're using? We have designed floating platforms, sort of, but primarily, we're testing for other people. So we have a big test facility down below, So, and what we do is we examine, test their technology, see how much they move and how well they react to wave conditions, So that's floating wind, So floating wind is the next thing that will happen in terms of offshore renewable energy. Sort of after that, I would see tidal energy. So there's been developments in tidal energy already in terms of small-scale arrays, but tidal energy still costs too much, so they need to make more optimizations to get the cost down.
And how does wind energy compares to solar energy? Solar panels?
Well, I suppose, sort of if we're looking at Northern Europe, sort of wind, we're obviously in a very windy location, so wind makes sense for us more than solar at the moment, sort of, and solar, I suppose, wouldn't be regarded as a sort of an offshore resource primarily, sort of, there's a lot of sites on land where you could have solar, so we're focusing on what you can put offshore, which is wind, wave and tidal.
And you mentioned that, I know in this building you have amazing test facilities for testing this new equipment that is being developed. But I remember, when I visited your center, when it was HMRC a few years ago in Tramore Road in Cork, you also had some test facilities. You have a wave tank.
Exactly.
And what I'm curious about, how does this new test facility compares to what you had there? Is it more advanced, or is it?
It is, sort of I think, sort of the test facility we currently have puts us on a par or better than any other facility worldwide, whereas previous to that we weren't at that level, so, and as well we currently have the full suite of test tanks required to develop technologies from initial concepts and ideas to a stage prior to them going offshore, so there's a process for developing technologies that starts off at a very small scale model. Then before you go offshore, you build as big a model you can in the tank and test that, and we can do all of that now, whereas in the past, some of the testing that would have been done in Ireland would have gone to other countries in Europe. So we have all the equipment and facilities required to test these technologies to pre-open sea deployments.
And is it the most advanced test facility that exists in Ireland of this type, or
it is? It's, I think, sort of what sort of the good thing about MARA is that we're focusing our efforts in terms of the different universities. So UCC, in terms of marine renewable energy, focuses a lot on the testing, and the other universities don't. So we're the main infrastructure in Ireland for testing marine technologies. Sort of the NUIG would be testing, say, structures, like tidal blades and things like that, and Maynooth University then would be looking at the control systems for renewable energy technology. So we all have our own particular area of expertise, and I think that's one of the benefits of the MARA Centre in terms of optimizing our limited resources that we get from the government.
In terms of the design of these test facilities that you have in this building, who designed it? Was it yourself, or?
Well, there was a team of us. So we were sort of the practical users of it. So we obviously had an input into the overall design, but then sort of you have to get involved with builders and architects, and then there's the financial issues as well. How much money is available and what we can do for that money. So all of these things were factors in the final design that we came up with.
So I guess wave energy is very exciting kind of new topic, and what's your opinion about wave energy?
I think wave energy has incredible potential for Ireland in particular, sort of because we have a huge resource off the south and west coast, sort of that if we could develop a technology that would work efficiently and at low cost, then so we have great potential, but I suppose that's the challenge at the moment, and that's why it's a great research topic, is because nobody has got to that stage yet where they've developed a technology that works properly in that environment, and there's ongoing work to do that. So we're very excited by a lot of the projects we have. Trying to get wave energy forward. So there is a company, an Irish company at the moment, deploying or planning to deploy a full-scale device in Hawaii that we developed all through the different stages. We tested it at a small scale, medium scale. We were involved when it was in Galway Bay, and now it's going to be deployed at full scale over in Hawaii.
Are you part of the Smart Bay project in Galway?
We're not, but we're part of the test site. There's a test site group, So in Ireland, we have 3 test sites. We have the Lirt National Ocean Test Facility, which is here in this building, which tests at laboratory scale. So when you finish at laboratory scale, you go to open sea environment at quarter scale, and that's Galway Bay, where Smart Bay is. So that's the test site. And then once you finish on the test site, the plan is that you go to AMETS, which is the Atlantic Marine Energy Test Site, where you would test at full scale. So that is the stages of development, and Ireland has all the infrastructure needed to be able to take a technology from an idea. Somebody walks in here with an idea to a full-scale prototype deployed in an Atlantic site. So we have that capability in Ireland.
And with current technologies, when we talk about wave energy, are we talking about devices which are installed far offshore? So you're facing the challenges of storms and bad weather conditions.
Well, it's better offshore rather than close to shore.
But sometimes, people who go surfing, they know that the power of waves is quite strong near shore as well. So is there any technology to actually utilize the energy of waves in the intertidal area? Breakwater?
I'm not. There are ideas, and I'm involved in a project at the moment looking at, sort of renewable energy for ports. Can you put wave energy devices on port structures like breakwaters, but in general, the energy resource reduces as you come closer to shore, due to the waves losing energy in bottom friction and breaking. And I suppose, a big issue when you get less than 50 meters water depth or less in the west coast of Ireland is that you have breaking waves, and they put the biggest loading on structures, so generally you don't want your structures to be located where you have waves breaking on them. So my view is that if they were, 50 to 100 meter depth, that would be more optimal. There's one example where we were testing a device in our tank, and we had the equivalent of 50 meters, and the loads on the mooring were huge. And then we dropped the floor to change it to an equivalent of 100 meter water depth, and the loads reduced by 1/10 because the large waves weren't breaking on the structure anymore. So, there are advantages of putting it offshore because you have a cleaner resource, and less loading, compared to closer to shore where the waves are losing energy, they're breaking, and you don't have a clean or steady energy supply.
Okay, earlier on we spoke about engineering solutions to coastal protection, and in the context of potential rising sea level, climate change over the next 100 years. So we said it's important to set up all-island coastal monitoring program and think of better kind of solutions to protect the coast. But as now you mentioned the wave energy, what I thought maybe you're also working on similar ideas as well. Is it possible to actually combine coastal protection and wave energy, so the devices that you install offshore would be generating energy and paying for themselves, but at the same time be the part of the coastal protection, like offshore breakwaters, which gonna somehow utilize the energy of waves and at the same time protect the coast?
I think that has been an idea that has been purported, and I think that there has been some research done to show that wave energy devices can have a positive impact on coastal behaviour. But my view overall is that it probably wouldn't be that suitable, because I suppose wave energy devices, if you understand how they work, they operate up to a certain wave limit, sort of maybe 6 or 7 meter HS offshore, and then they shut down, they go into survival mode, so they're not extracting energy when you have the biggest storms and when you have your biggest impact. And a lot of our coastlines is when you have the large storms, so, and also what happens is if you need them close to shore, and there's a lot of objections to devices being close to shore, and you know, say from the surfing community in particular, like they wouldn't want these devices taking energy from the waves and maybe impacting their surfing conditions. Like just to give an example,
it's going to be low on priority list if we're talking about rising
That's
sea
right.
level.
Yeah, exactly. Yeah, like I remember there was a project I was involved in, it was Doolin Harbour, and I don't know if you know Doolin off the Clare coast. There's a very important surfing spot there, and when they were designing the harbour, they had to design it so that the reflections from the new harbour was below a certain limit. So we had to test it in our tank to show that the breakwater being constructed had reflections that wouldn't impact on the surfers when they were coming in. So, you know, when we're doing anything on the coastline now, we have to be cognizant of all the players, stakeholders that we have to deal with, you know, sort of that there's a huge amount, and they all have their own sort of priorities, which may not be the same as ours, but we must consider them, you know, So yeah, it continually surprises me who would object. You know, say for instance, offshore wind now. There's a lot of objections of people being able to see wind turbines in the distance. So we should put them further offshore, so they're not visible from the shoreline. You know, so all different aspects now. You know, sort of in terms of public engagement and public acceptance of what we do in our marine environment.
But are there any devices which are capable of extracting electricity if they're installed on the seafloor from the current, like some sort of like wind power turbine, but like water current turbines?
Tidal turbines are do just that. They're placed in an area of high flow, and they extract energy from that then based on.
But in this case, they can be used as natural wave breakers, no?
Yeah, but they still wouldn't take enough energy out of the waves, and especially during a storm conditions where you have elevated water levels and you have bigger waves. You know, sort of you don't dissipate enough energy. I did tests years ago on submerged breakwaters, detached breakwaters. You know, sort of that the crest level was below the surface, but we found that they didn't have a big impact on the coastline because they didn't take enough energy out of the incoming waves to be able to significantly reduce the conditions on the shoreline, you know. So you kind of, during average wave conditions, you may have an impact, but then during the big ones, which can sometimes be the most critical, these structures wouldn't play a part in protecting the coastline. Yeah.
Okay, thanks very much, Jimmy. So now probably we can go and have a look at your facilities.
I can show you that. Yeah.
Okay,
Thank you. Thank you very much.